this network address translation. Great chance you will see a question on NAT on your exam. There's 3 different types. There's static NAT, dynamic NAT, and PAT. Right? Somebody had to think long and hard to come up with that. Maybe they were watching Saturday Night Live and remember skip with Pat. So let's talk about these and how it does what it does, right? So it maps your internal IP scheme, so your LAN to the WAN. So it takes your LAN, your internal IP scheme, and gives it a WAN address, and then when data comes in from the internet to your WAN address, it'll translate it into your internal IP scheme. And so this is how it works. Each private IP is mapped to a single public IP. This is with static NAT. Usually what we're trying to do with this is we don't want the bad guys to know, or anybody really, to know what our private IP space is. So we try to hide it using NAT. Static NAT usually is labor intensive, and so it's not used as much anymore. Dynamic NAT allows us to really reduce the number of public IP addresses that we need in order to communicate out to the internet, right? So if we have these private IPs that we can group or pool together to have a single public ID. And so what we can do here is we can kind of segment them logically, whether these are on virtual LANs or whatever, and then say, you know, this one address is linked to these 4 machines. It translates it over to one of these network interface cards that's facing the internet. And that way, these guys that are out on the internet only see these 4 for our entire organization. And, you know, our organization might have 100,000 people in it. And so we need to break it up in a way that's meaningful. And so the last one here is this port address translation, where you can map each public IP address up to and try to reduce the number of public IP addresses by using ports. Yes, that is correct. That's how most home networks are now. Yes, sir. You're correct. And what we try to do is establish a session for each of these private IP addresses to a specific port. And so usually ports are denoted here by a colon. You see the colon right here. And whatever port it's running on. And there are 65,535 ports. Every one of those you will need to know for your exam. No, I'm just kidding. I'm just kidding. You don't need to know all 65,535 ports. Really, I think the ones that I said earlier, again, let's see here. These guys are the services, and you need to know the associated ports of that. You look at what I wrote earlier, you remember there's one on there, NAT. That's what we're looking at now, right? All right, so let's keep on going. So there is another thing here that you probably should know. It's the Internet Control Message Protocol, or ICMP. Usually, this is what people commonly know as the Hunt for Red October, or Give Him One Ping. If you've seen that movie with Sean Connery before, Give Him One Ping. So the ping is how we troubleshoot issues on the network, and that is done through what's called ICMP, Internet Control Messaging Protocol. So if you've never pinged anything before, then I would suggest that you learn how to do that. because it can be very useful for troubleshooting issues on a network. Most of the time, ping is disabled on modern networks. Ping is disabled. All right, the last thing here that I want to talk about is this thing that's called IPsec. IPsec, or IP security. And what this does is it gives us the ability to really VPN. Gives us the point-to-point tunneling protocol using layer 2 tunneling protocol typically. And it allows us to associate a few different components. One of them is this authentication header. Second one is the encapsulating security payloads, or ESP, not to be confused with ESPN. And then the last one here is the security associations. It can run, IPsec can run in 2 modes of operation. One is transport mode, where only the payload is encrypted, so the authentication header is unencrypted there, right? It's sent in clear text in the transport mode. Or the tunneling mode, where both of them are encrypted, the authentication header as well as the encapsulated security payload. There is a performance hit for encrypting everything. It is subtle enough. However, when COVID hit and so many people were using VPNs in 2020, many of the VPNs started to look at different ways to do it, and quite a few of those VPNs switched to using the transport only mode. So because a concentrator may had, before COVID, may have had, let's say for the Army, 10,000 people simultaneously using VPN. I'm just throwing out a number. When COVID hit, there was 1 million people the next day that were using it. And so there had to be a way that, hey, either we buy more elasticity with Amazon or Google or Microsoft, or we need to go out and buy all sorts of crazy new hardware. And so there has to be new ways that we can innovate and invent. And so one of the concepts was to remove the authentication header, because with low numbers, the hit on performance isn't as high. But when you have so many more transactions happening per second, it subtly makes up, what's typically over time, the sum of the whole ends up being more of a hog of a bandwidth and network. Okay, any questions on that? IPsec also uses this thing that's called key management. And so those security associations here that we were talking about uses a thing called ISC2, as well as another protocol that's called Oakley. And then it actually will exchange the keys using this scheme. And you can go and read about this a little bit further. I've got some great YouTubes on great YouTube videos on the CyberProtex YouTube about all this. We have over 500 videos out there on the CyberProtex YouTube.